Also this morning I'm messing with the settings in the OBS studio, so if my audio drops out, let me know, because I know that tells me I need to fix the problem in the program. But yeah, hopefully this will make transitions between the different tools a little bit easier to see. Oh, there's 4 of you lurking in the background. Ooh, the latency is so much better today. Does the final step of the discussion board today have a particular solvent associated with it? Well, let me take a look at this discussion board and find out. So, okay, chemistry. So, not really, and actually a major problem with this type of reaction would be that you would want to remove all the solvents. Let's see here. Okay, sorry, I'm looking at step to number 1. Actually, that would be pretty challenging. My guess would be that you would run this probably in ammonia, since they're both going to get combined together. Realistically, you probably have to do a purification step and run them in a solvent of your choice. My best guess would be that you would purify the sodium azide, the NaNH2 product, and then dissolve it in a solution. Since this is isopropoxide, you probably run in an isopropyl alcohol. So if I had to guess, I would say the common solvent for 2 and 4 is isopropyl alcohol, with that sodium azide being run in ammonia, and then you extract off the ammonia and the sodium azide, purify it, and then recombine them. So practically this would be a pretty involved synthesis. I mean, it's great to write what's written in this scheme, but the reality is you would have to purify at least one product, since I'm guessing that sodium azide is going to react pretty aggressively with isopropyl alcohol, and you don't want the ammonia around. But to answer your question, no. If I had to guess, isopropanol. That's more of an organic 3 level kind of question. And I did have questions like that when I took organic 3. Was that okay? What are you going to have to do in order to run this synthesis? Because that was the big thing with him, is that if you're constantly having to change solvents, you're constantly having to purify your product, which means you're constantly losing product along the way. So ideally, you would run it in one universal solvent. I don't know if you could run isopropyl. I'm thinking about it in my head right now, but I'm thinking the isopropyl alcohol, you could probably react away all that sodium azide, but again, that sodium azide is being run in ammonia, and I don't necessarily know if the ammonia is going to affect the reaction. There are practical aspects of synthetic organic chemistry. So the big one I wish we would switch to is biodiesel. There are legitimate arguments against biodiesel under the grounds that the methanol that's used to make biodiesel is actually more valuable than the biodiesel that's being produced. And they are correct. If you look at a cost analysis, biodiesel is substantially cheaper than the methanol being used to make it. That said, what gets left out of that analysis is methanol is a highly flammable, highly volatile liquid. And so it has special storage containers associated with it, especially if you want to use it for transportation purposes. Biodiesel does not. You can pour a gallon of biodiesel out into nature and it won't do anything. Whereas methanol, you would need to contain the spill and remove the spill. So while methanol is more valuable than biodiesel, it also has a higher cost associated with storing it. So I've never seen that analysis worked out to say, well, yeah, we could burn methanol in a car, but what's it going to take to store it safely in a car and store it safely at a gas station versus biodiesel, which effectively has no storage considerations associated with it? But good question, right? Like, there are practical sides of this. It's great to write these arrows out and say, oh, do this reaction, but you saw in there earlier you had the H2PT. I've run that reaction in an organic 3 lab, and the group behind me learned the hard way that if there's any air in their system, it's going to ignite the hydrogen. And that's what it did. It shot the rubber stopper off their glassware. I mean, that's why we use the rubber stopper, is that it basically works as a vent valve. But it ignited their reaction mixture and shot it up into the ceiling. So it's great to run the H2PT, but there's a practical side of that you need to do that under air-free conditions, or you're going to ignite the hydrogen on the platinum catalyst. Most likely you would use a Schlenkline technique for any of this anyway. Most of what I've got on there are fairly air and water sensitive reagents. I wish we could teach you Schlenkline techniques. They're actually very cool techniques and they're pretty intuitive. You have to get a little bit more feeling with it. Definitely not something I would send you alone to go do in the lab, but definitely it's like the Rotovap. You do it a few times, you're like, okay, this kind of makes sense, and you see how there's a lot of safety features built into Schlenklines, so if something does go wrong, the Schlenkline doesn't explode. For lab report 2, do you want a separate solution page, or can I highlight the answer on the same page as the problem? You can highlight it on the same page as the problem. As long as I can find your solution, actually I would rather you do what you're proposing here, which is write it right underneath your question, so I can just quickly see it. I don't have to constantly, in Blackboard I can kind of view one page at a time. So if I see your problem and then I've got to scroll down to your solution, I'm not going to take up points for that. It's just, from my side, it's a lot more practical if your solution is right beneath your question. Precipitate formed on 421. So you actually had a couple reagents sitting in there. And actually the big one you had sitting in there was this compound. So this 1,3-hexadiene, cyclohexadiene. And so the trick with this is to realize that there's two of these molecules floating around. And what can happen is that it can perform Diels-Alder on itself. So something to that effect. This can further react to form another link, which can react with another link, and so forth. And so the precipitate you get is actually this polycyclohexadiene product. And this is kind of a hard fact about Diels-Alder that doesn't really get discussed in books. I talked about it in the last live stream. I've had to deal with this, that when you do deal with Diels-Alder products, they can react with themselves. And because they can react with themselves, Usually you want to keep these at low concentrations, but practically when you order the chemical from the supplier, they keep it in high concentrations to reduce shipping costs. So particularly with what I was working with, I had to decompose it back into the diene before I could actually run the reaction. All right, product number 4 on the discussion board today. So go back to it. Man, I do love me some Diels Alder. Okay. So let me go ahead and write the reactions up. So we have H2PT, sodium azide, not azide, whatever that is, Cl2, and your isopropoxide. And the two of these are going to react to form product 2 and 4. So thing here is that, and I can already tell what I'm doing up here, this is going to be a Diels Alder, but it's going to be a Diels Alder with an alkyne. So how did I get to that? Well, I've got H2 and PT. So my H2 and PT is going to form this product. Now, I do not care about the stereochemistry because of this next step. This sodium NH2 is going to do a double elimination, and so I'm going to end up with 2-butyne. Now, this step here is very intentional. We're going to add the Cl2 to do this. The reason this is intentional is that when we add the isopropoxide, it's going to force elimination towards the methyls, or the terminal methyls. If I added the hydrogens here and I did the isopropoxide, I would end up just forming a double bond. Now, the other thing is that the isopropoxide is not a good enough base to drive this to an alkyne. It's only good enough to drive it to an alkene. And so what we end up getting on this step is this diene. So this purpose of this problem was, one, to refresh your memory on alkene eliminations, additions to alkenes, and then how to form alkynes. The next step here is getting you comfortable with Diels Alder of alkynes. Now, Diels Alder of alkynes is going to look like Diels Alder of alkenes. The big difference is that when we do alkenes with Diels Alder, we always end up with one double bond. When we do alkynes, we end up with two double bonds and they're on opposite sides. So the product of any alkyne with a diene is going to be your 1,4-cyclohexadiene. And we're going to take the same approach. We're going to number our carbons, and we're going to also letter our carbons. So for my alkyne, call this alpha and beta. And then for my diene, 1, 2, 3, 4. Now, one double bond is going to be between the second and third carbon, so we can do 1, 2, 3, 4. And for our alkyne, the alpha and beta are going to be the other double bond. Now, the reason I picked these reagents is that it's a symmetric reaction, so you're just going to end up with one product no matter how you put them together. So if you look at the alpha carbon, it's got a methyl. If you look at the beta carbon, it's got a methyl. The 2 carbon has a chlorine, and the 3 carbon has a chlorine. So this is how you get to the final product in this reaction. Your alkyne reacts to the diene that you generate through this process to give you the dichloro dimethyl diene. Which one of you called yourself Tasty Tide Pod? I mean, I get the joke, I just don't know who that is. And kudos on the joke, by the way. Okay. what did I actually ask you to do with that problem? Sorry, bring the problem back up really quick. The name of this compound, that's actually a really good question. Sorry, I wrote these questions like a month ago, and so like it's nice to look back like, wow, that was actually like a well thought out question. Good for you. Like, do you ever look back at your work and go like, wow, that was actually really well thought out? Like, I'm impressed I actually accomplished that. I mean, they haven't all been like that. Like, there's a couple I look at, I was like, oh, yeah, you didn't think that through, did you? Like, you thought this was the answer, but it really wasn't. Any general questions you might have for me today? Certain level of difficulty. No, not really. I mean, so you see this with the packets. Like the packets are varying levels of difficulty. They start easy and then they go hard. Um, if you want to do simple problems, you can, but there is a reason why in the restrictions it tells you like there's certain problems that need to have certain components to them, and that's to get you above like straight knowledge based questions. I think there's like it requires you to do a synthesis for one of them. So the assignment is designed to keep you from going like super softball and give me 5 really trivial questions. But if you want to do, I think it's like you have to do one actual like challenging question. The rest, if you want to do the rest that are trivial, go for it. This is more meant to help you study. It's also meant to kind of give me a resource for problems. But I don't need like 5 GMAT level questions. Like if you want to do one hard question, the rest are easy, by all means. This is a study guide for you. I hope you've kind of seen it this semester is that we try to keep the synthesis to like, or we try to keep the problems to like 2 or 3 steps at most for synthesis. Again, the big reason, 2 big reasons for this. One, this is not organic 3. Organic 3 will have like 5 to 10 steps involved in the synthesis. The second is that it's just more teaching style. You can lose the forest in the trees. If I give you a 20-step synthesis, but really it's step 8 I want you to focus on, you're going to be so focused on the other steps, you're not going to get it. So for synthesis, usually 2 to 3 steps, just so you make sure that you're testing, particularly on my end, it's making sure that you're understanding the core concept while as making sure you haven't forgotten the other concepts. And again, I hope you've kind of seen this with the synthesis problems I've given you. There's always some throwback to the earlier part of the semester, but usually, definitely one of the steps contains something we're talking about this week, with the idea that I don't want you to forget the old stuff, but it's not the focus. The focus is the new stuff. But again, make sure you don't forget the old stuff. And you'll see this particularly when you take organic too. There's a lot of callbacks to earlier stuff saying, oh yeah, this does this, you probably already know how to do it. And hopefully you do. You'll see when you take organic too. So any other questions or just out of curiosity for the people who are streaming right now, what resources are you using for this course right now? Like which ones are you finding most useful? Because I am teaching this online in the fall, so I kind of need to have an idea as where to send my students in case they have questions. Well, looks like y'all are actually pretty good to go today. So I'm gonna go ahead and let you sign off. Thanks to all y'all who could show up today. Definitely send me emails or message me in Teams if you got questions. Again, don't forget that second lab report. You do have a lab practical next week, but the discussion board you do need to respond to. Notes, videos, textbook. I've never read Wade's book. But yeah, you do have a lab practical next week. It's online. I checked over it one more time to make sure it's good to go. I promise you it's not going to take you 2 hours and 50 minutes. It's probably going to take you about an hour at most. Do email me if you have issues. Please go ahead and try to knock it out early next week so I can go ahead and get your lab grades posted. Other than that, we've got 2 live streams left, 2 for next week. Then you've got your final exam. Details of the final exam are on the course website. So if that's it, I will see all of you next week. Thanks for showing up.